All right, so solving systems of equations by graphing. How many of you remember how to solve by graphing? How do we know what our solution is? All right, great. Well, we'll figure that out here in just a minute or two. So we're going to start with an equation, or a system of equations, that are both in slope-intercept form. So we have the equation y equals negative 2x minus 4, and y equals 0.5 or 1/2 x plus 6. And we're going to graph those two equations. And I'm going to graph them in different colors. It doesn't matter, but that way you'll be able to tell, oh, the blue line, that's negative 2x minus 4. And the red line, oh, that's 0.5x plus 6. Just to make it easy. All right. So if I graph negative 2x minus 4, where should I start?
I'm going to guess.
You give it a shot.
I have an idea. On the negative 4 on the y-axis.
Negative 4 on the y-axis, right. This is our y-intercept. So that means that crosses the y-axis at negative 4. Then what am I going to do?
Since it's negative, it'll go down, right?
Yep. So I'm going to use my slope and go down 2 over 1. And I could do that as many times as I wanted to. One thing with solving systems by graphing, you want to make your graphs relatively big, okay? Just so that you can see where the two lines cross. So as you see, I went from negative 10 to positive 10 in both directions. On your homework assignment, I have pre-printed grids. So the graph paper will be right on your homework assignment. Make it a little bit easier. So let's see, blue, both of those, and I draw my line. How many of you would prefer a ruler for drawing your lines? Again, the more accurate your line, the better. Oh, you've got one. Look at that. The more accurate your line, the more accurate your solution. So if we use the same idea, where should I start for y equals y equals 0.5x plus 6? Six is going to be the y-intercept. Slope, 0.5. Now, I don't like decimals as slope. I like fractions. So I'm going to think of this, and the reason I like fractions is because we talk about slope as being rise over run. And so if I think of it as 1/2 instead of 0.5, I know I can go up 1, rise of 1, run of 2. And again, I can put as many points as I want following that pattern on my graph. And, ooh, that didn't go so well. Let's see if I can fix that up. There we go. And our solution is right where the two of them cross. And it appears to be at -4, +4. And we can always check, which is great. And we're just going to check. We're not going to write out the check, but we're just going to go kind of talk through it verbally. So if I take my x value, -4, and I plug it into the first equation, what is -2 times -4? Ooh, 8. There we go, 8. And 8 minus 4 is 4, which is what it says I should get. And if I check the other one, what is 0.5 times -4? Or what is half of -4? -2 plus 6, 4. The y value for our solution. That's good. That means our solution is correct. We got the right point of intersection. All right. Moving to the next one. So we are going to work on this one. So when we solve a system, we could have a solution, one point of intersection, great. What else could happen? There could be no solution. The lines could not intersect. That might happen. Or we could have, and in the past we said infinitely many, but we're going to show you, we're going to be a little more academic, and we've got a different way we're going to write our solution if we have a bunch of solutions. All right, so y equals 2x plus 3. If I follow that pattern from the last problem, point at 3 is my y-intercept. Slope of 2, I rise 2, run 1, rise 2, run 1, and I can do that often. Now our second equation gives us a little bit of an issue because it's not in slope-intercept form. So we have a choice. And I'll tell you how I make my choice. If the y is by itself, I'm going to write it in slope-intercept form. I'm going to move that minus 2x to the other side of the equation, and then it's in slope-intercept form, and we can do it that way. So one way to deal with this, how do I move the minus 2x? Add it, yeah. And then we want to be careful. That makes it 2x plus 1, not 3x, right? And now it's in slope-intercept form. I can graph it just like I did the first one. So intercept of 1, slope of 2. What is it? No solution. When the lines are parallel, we get no solution. Excellent. All right. Third example. Y equals 2x plus 3. Again, slope-intercept form, that's good. I'm happy when I get slope-intercept form if I'm solving by graphing. Makes things a little bit easier. Must not have been feeling very creative. I used the same equation twice. Now, negative 4x plus 2y equals 6. Here I don't have just y by itself. So I'm going to do a little bit different. And I'm just going to pick some points, some values. Like I might let x equals 0. I like 0. Because if I let x equal 0, I can cover up the negative 4x and solve the equation 2y equals 6. And if 2y equals 6, what does y have to equal? 3. Right? Divide both sides by 2. So I'm going to 0, 3. And I'm going to plot that point. Then I can pick another value. And some people like to use like 0 for y. So if y is 0, I cover up the y. And I have negative 4x equals 6. That really is a 6. So what is x? It's going to be negative 1.5. So, and you certainly couldn't use a calculator to figure that out, right? 6 divided by negative 4, which puts us over here. And what happens is we get that line. We have the same line. And so when we first learned about doing this way back in intermediate algebra, or maybe even algebra 1, we would say, oh, there are infinitely many solutions. There is a more exact answer, and that's the one that I'm going to show you right now. So our answer, we're going to write it in what is called set builder notation. We're going to use this, first we're going to make sure we have the pen active. There we go. And we're going to use